So the first thing we would like to discuss is the concept of arc length. So let's have the following motivational problem. Find the length of the arc of the parabola y equals to x minus 1 the whole square between 0, 1 to 3, 4. Now there are a few arc lengths we are already aware of. So for example, even though we haven't seen the proof of it yet, but we'll see the proof of it soon, that what is the arc length of a circle, right? We know that if you take a circle of radius r, the arc length of this whole is 2 pi r. Yeah. So similarly, we want to see what is the length of this blue curve here. So the idea is, so our approach is, we will first approximate it with number of straight line segments. So first, approximate it with this, with a number of straight line segments, and then, so the idea is to suppose here, I will break it into few line segments. I'll try to find out length of each of these segments. Okay. So, right. So we'll try to find out length of each of this segment and add all of them up. So we would like to first approximate by number of line segments, but of course this is going to be not accurate, right? This is going to be, if you join these guys, this is not going to be accurate. So what we'll do is, to make it accurate, we'll take the limits, then take the limit as the number of segment increases. So let's see here. Suppose you take a small part of it, a line segment. So then this change in x would be delta x. So that is going to be x equals delta x equals to xi minus xi minus 1. Suppose this is xi minus 1, this is xi. And yi, change in y would be what? Change in y. This would be your change in y. This is your delta x, this will be delta y. Delta y is change in y, which is going to be yi minus 1. Now, this length from here to here, let's call this as this point to be pi minus 1, pi. Then we get from Pythagoras theorem, pi minus 1 pi square equals to delta x square plus delta y square. Now, to make sure that this I comes into the picture, we'll basically label it by delta xi. So this is just one small piece here. All right. So this is one small piece, and you're going to add all of these pieces up. So therefore, arc length is going to be L, which is limit as n goes to infinity of summation I going from 1 to n, absolute value of pi minus 1 pi. Yeah, so the idea is you have a curve like that, and you're basically putting small line segments, and you're measuring the length of these line segments. All right. So one of them is zoomed here to c. Now, if you write it, if we open it properly, so limit as n goes to infinity, this is going to be summation I going from 1 to n, delta xi square plus delta yi square root. So then we have the following. If we use the mean value theorem, we can always find. So we have, or we can use the concept of differential to see that delta yi is going to be sum f prime xi star delta xi, where xi star belongs to xi minus 1 to xi. Yeah, you could see that from the mean value theorem, right? Mean value theorem tells you that if you take f of xi minus 1, so f of xi minus f of xi minus 1 is f prime xi star xi minus xi minus 1. Yeah, this is a mean value theorem, right? So what do I get? I get delta yi is this. So therefore, arc length L is going to be limit as n goes to infinity, summation I going from 1 to n, delta xi square plus, instead of delta y, I'm going to write yi xi star the whole square times delta xi square. Now I can take limit as n goes to infinity, take delta xi common, so we have 1 plus fi xi star the whole square root delta xi. And if you compare it with Riemann sum, this is going to be integral of 1 plus f prime x the whole square x, and integral limits are from a to b. That is not explicit here, but you are looking at the function. So your function is from a to b, and you made few line segments to do the approximation. So this is how the game is played. So you get the formula for the arc length. So let's look at the first problem. Let's apply this formula. So again, let a be yx minus 1 square. So find the length of the following arcs. Y equals to x minus 1 square between 0, 1 and 3, 4. So first of all, let's write down the expression for L. So L is, for the first one is 0 to 1. Sorry, 0 to, x is changing from 0 to 3. So 0 to 3, 1 plus, in bracket we have f prime x. So f prime x can also be written as dy by dx the whole square, because there's no f here, right? We are not using f as a notation, so we use dy by dx here. So we get, this is 0 to 3 square root of 1 plus, now what is dy by dx? So dy by dx is, in this case, is 2 times x minus 1. This is going to be 2 times x minus 1 the whole square dx. The whole square dx. So now what we can do is the following. We can basically do a trig substitution to do this integral. So we can write let u times x minus 1 b. So 1 plus tan square theta is secant square theta. So let's take this as tan theta. So we get 2x dx equals to 2 dx equals to d theta. So, and when x is 0 implies tan theta equals to minus 2, which means theta equals to tan inverse of 2 minus 2, and when x is 3 implies tan theta is, when you put 0, we get when you put theta equals to 3, we get 2 times 2x becomes, so 3 minus 1, so it becomes 2, so implies theta equals to tan inverse of, so this integral will convert into L, which is tan inverse of 2 to, sorry, tan inverse of minus 2 to tan inverse of 2, and then inside we have square root of 1 plus this, so this is going to be 1 plus tan theta is secant square theta, square root of secant square theta is secant theta, and instead of 2x dx I'm going to write d theta by 2. So this is going to be tan inverse of 2 secant, so half comes outside, secant theta d theta. Now note what is secant theta. So secant theta is integral of secant theta is, so half ln of secant theta plus tan theta, tan inverse of minus 2 to tan inverse of 2. So now we need to compute what is a secant. So let's compute what is the value of secant. So we have secant theta is, when secant theta is 2, so we have, so tan is opposite side upon adjacent side. So if opposite side is 2, adjacent side is 1, this is going to be square root of 2 square plus 1. This is going to be square root of 5. So in that case, if tan theta equals to 2, then secant theta is going to be adjacent side, which is 1, sorry, hypotenuse upon adjacent side, so square root of 5 over 1. So similarly, when you have minus 2, the same story follows. So when you substitute these values, you will find that the answer is roughly 6.126. You can do that computation. Yeah. So this is problem 1. Now, similarly, we can look at problem B now. So we have x equals to 1 by 6y cubed plus 1 by 2y. Y is between 1 and 2. So in this case, we need to write everything in terms of y instead of x. We have tan inverse of minus 2 to tan inverse of 2. And then when you substitute, you'll actually get this is roughly 6.126. Okay. All right, so let's look at problem 2 now. So B. So we have x equals to this, and now we want to write down everything in terms of y. So in case you're using y with respect to y, it's going to be c to d 1 plus dx by dy the whole square times dy. So it's very symmetric in y, where y changes from c to d. So let's see, in this case we have 1 by 6y cubed plus 2y. So we get, in this case, we have from 1 to 2 square root of 1 plus dx by dy. So what is dx by dy? Derivative of this. So what is derivative of y cube is 3y square. So it's going to be 2y square. So 2y square minus, what is derivative of this part is going to be minus 1 by 2y square. Minus 1 by 2y square, the whole square, times dy. Now let's expand this out and see what do we get. So this is going to be 1 to 2 square root of 1 plus 4y square, y4, my bad, plus 1 by 4 y to the 4, and then 2 times ab. So 2 times ab will give me, so this and this will cancel. I'll get, let's square it. So what do we get? We get, take y square, so y to the 4 over 4 minus 1 by 4 y plus 1 by 4 y to the power 4 plus, if you multiply this out, plus 2 times plus, sorry, minus 2 times y square by 2 times 1 by 2 y square. So this will become, so when we simplify, we can take 1 by 4 out. So when we take 1 by 4 out, it comes at 1 by 2, 1 to 2, 4 plus y to the 4 by 4. So now the 4 goes away, plus 1 by y to the power 4, square root is still there, and then we have this guy cancels with this guy, so we have times, so expansion is a b, so minus 2ab, so y square will cancel, so we'll have 1 by 2 times, so we get 1 by, right? So if we can, you don't need to take 1 by 2 out, then we can just basically, if you notice that this is with a minus sign, and when you add 1, you get y to the 4 by 4 plus 1 by 4 y square plus half. So you see, expansion of this here had this thing with the minus sign. So if you replace this center thing with the plus, it will become, it will become 1 to 2 y square by 2 plus 1 by 2y square, the whole square, square root dy. Now, so we get, this is going to be 1 to 2 y square by 2 plus 1 by 2y square dy. This is going to be y cube by 6 minus, so plus minus 1 by 2y, 1 to 2. And let's put in the limits. So this should give us 2 cube, which is 8 by 6 minus 1 by 4 minus 1 by 6 plus 1 by 2. Okay, so this is going to be 7 by 6 So we get 7 by 6. 7 by 6 and then plus 1 by 4, which is going to be 4. It's a 24. 24 plus 6, 30 by 24, which is going to be, so 6 5s are 6 4s are. So this is the integral. Now let's talk about the arc length function. So what is an arc length? So the idea is, let S be a smooth curve for y equals to f of x, where x goes from a to b. So you have a smooth curve between a to b is given by y equals to f of x. Now let's fix this point. Now at any point x, you can talk about what is the length from here to here, right? So this length is what is called as the arc length function. So we are trying to find out what is the length from here to here, yeah? And that length is basically your s of x. So s of x is a distance from along the C from initial point. So this is your initial point, right? Your initial point is P0, which is a comma f of a. And from here to x, this point is Q, which is x comma f of x. So you're finding the distance between them. And this is s of x is called the arc length function. Yeah, why is it a function? Because it measures the distance and it changes as you keep changing x. So if your x is here, then the distance will change from here, right? So the distance will increase, right? So this is the arc length function, and s of x is given by a to x 1 plus f prime. Now I'll write t the whole square dt. So now find ds by dx. So what is dx by dx? So ds by dx is, by definition, is derivative of this, and recall by fundamental theorem of calculus, that is going to be 1 plus f prime x the whole square root. Okay. Now what is my ds? My ds is then square root of 1 plus f prime x the whole square dx, which is square root of 1 plus dy by dx the whole square. And then when you bring dx inside, we get dx square plus dy square. So this is what differential ds is. So you can also think about it as a Pythagoras theorem. This is dx, this length is dy, this is dx, so ds square is equals to dx square plus dy square. So let's look at the following problem. Find the arc length function for y equals to 2x to the power 3 by 2 starting from P0, which is 1 to 1 comma 0. So now we have P0 is 1 comma 2. So we need s of x. The function is given by the following formula: 1 to x 1 plus f prime t the whole square dt. So this is going to be integral 1 to x 1 plus, what is f prime t? So f of x is, or f of t is 2t to the power 3 by 2. F prime t is 3 times t to the power, so 1/2. So this is going to be 3t to the power half the whole square dt. That is going to be integral 1 to x square root of 1 plus 9t dt. Now, if you integrate this, we can use the power rule. So this is going to be 1 plus 9t to the power half plus 1, which is 3 by 2, divided by 3 by 2, which is 2 by 3, 1, 2, and then divided by the coefficient, which is 9, 1, 2, x. So now you get, when you put this, you get 2 by 27. When you put x, you get 1 plus 9 x to the power 3 by 2 minus, when you put 1, you get 10 to the power 3 by 2. So this is your arc length function in this case. Okay. Yeah. The next concept we are interested in is the area of surface of revolution. So let's look at the following example. The idea is, if I take this y equals to square root of x and I rotate it around x-axis. So if I rotate it around x-axis, this is the surface I'm going to get. So I will get so this is the surface I'm going to get. And the idea is, so the question is, what is the area of this surface? Yeah, so what is the area of this surface? I'm going to use slightly different color for the background so that you can see the difference. So what is the total area of this surface? So that is the question. So now again, what we do is the following. We basically make a small slice like this. And then we ask, what is the area of a slice like this? So area of slice like this is basically, it's a cylinder. So now the radius of the cylinder is given by the function. So it's given by y, which in terms is given by f of x. So radius is y equals to f of x. So y equals to f of x. So let's write that down neatly. So here we have y equals to f of x. So that is what the radius is given by. So surface area of a cylinder is what? Pi r square h, right? If you have a cylinder and you want to find out the surface of the cylinder, you basically need to know the base circumference, which is 2 pi r, and the height is h. So same thing here, it will be 2 pi r h. So here r is f of x. So what do we get? We get, so circumference is is equal to 2 pi y, which is 2 pi f of x. And what is the width? The width is going to be, so for each part, we have the arc length as the width, right? So this is your arc length, piece of arc length. So we get, this is going to be, so surface area is going to be, 2 pi f of x. And now we need arc length. So we'll convert this into an integral. So it's going to be integral a to b, if your region is from a to b, then it's going to be 2 pi f of x as it is. And for L, we have the integral. So f prime x square dx. Yeah. So each piece basically, when you rotate, becomes a becomes a cylinder, and by integrating, you're adding all those cylinders up. So these are the formulas. So this is the formula we got from the previous one. And we can do the same thing. We can revolve the same thing along the y-axis. So I'll come to the formula of that in a minute and how to derive it. But let's first do a problem. So we have A. We want to find out the surface of revolution, surface obtained by rotating the given arc about corresponding axis. So we are rotating y equals to square root of x about x-axis. So y equals to square root of x. So we are rotating this about x-axis. So we have y equals to square root of x. That is the length here. So what do we get? We get S, the surface formula, the area of surface formula is integral A to B. Again, we don't need to, we can basically get what is the radius in this case. The radius is given by y, or 2 pi f of x. And then the piece of arc is given by 1 plus dy by dx, or f prime x, the whole square dx. So in this case A, we have f of x equals to square root of x. So which gives us f prime x equals to 1 plus, so f prime x is 1 by 2 root x, and therefore s is integral. What are the values of x? X changes from 0 to 2. 2 pi f of x is square root of x. Inside we have 1 plus f prime x, so 1 plus 1 by 2 root x, the whole square dx. So now if we simplify it, so this can be written as 0 to 2, 2 pi outside, square root of x. I'll take 2 square root of x square outside, so this will become divided by 2 square root of x. Then this will become 4x plus 1 dx. So these guys will cancel off. So we are left with 0 to 2, pi outside, 4x plus 1 dx. Now the integral is going to be 4x plus 1 to the power 3 by 2 divided by 3 by 2, same as multiplying by 2 by 3, divided by coefficient of x, which is 4, limits from 0 to 2. So this is going to be 2, this will cancel, so we get 1 by 6. When you put 2, you get 9, 9 to the power 3 by 2. Minus, when you put 0, you get 1 to the power 3 by 2. And if you want to simplify, 9 to the power 1 over 2 is 3, and 3 cubed is 27. So we get 27 minus 1, which is 26. The pi went missing at some point. We should put pi here, pi here. So we get pi 26 divided by 6, which is 13 pi by 3. So this is the surface of revolution. Right. Now let's talk about what about y-axis. So if you're rotating in y-axis, what will happen is, so let's do a rotation around y-axis for some curve. So we have certain curve, doesn't matter what curve is, and we want to rotate it around y-axis. So if we rotate around y-axis, the radius would become x instead of y. So it will be 2 pi x, and then length of arc will remain as it is, but we want to write everything in terms of y now. So this will be integral a. So either you write, if you want to write in terms of y, so this will become integral a to b. So now here you have this changes from A to B, and suppose Y changes from C to D. So to write that down, we have 2 pi. So now we have y equals to f of x and x equals to g of y, right? That's the inversion between them. So we have 2 pi. Instead of x, I'm going to write g of y. Limits of integration are c to d. And the arc length is given by 1 plus dx by dy the whole square. Now similar same thing about y-axis can also be written in terms of x. In that case, the expression will be simpler. We have x changes from a to b. So in that case, we have 2 pi x, because x is the radius, 1 plus f prime x dx. So you see the area element, sorry, the arc length element can be written as either this square or by this gy prime y. Okay, so let's see which one to use here. So we are rotating around x-axis. So, so we have B. So in this case, we have, again, S is, X is changing from 0 to 2 pi f of x, which is x cubed, square root of 1 plus dy by dx, which is dy by dx is 3x square, the whole square, dx. And to finish this integral, we can let, so this is going to be 0 to 2 pi x cube 1 plus 9 x to the 4 dx. So let 1 plus 9 x to the 4 equals to u. So this implies 9 times 4 is 36, x cubed dx equals to du. And the limits of integration will also change. When u is 0, when x is 0, x equals to 0 gives u equals to 1. And when x equals to 2, u becomes 1 plus 9 times 4. So 2 to the power 4 is 16. 16 plus 16, and then we have 16 times 9, that becomes 144. So 144 plus 105, 145. So therefore, S becomes 0 to 2, 2 pi. You can keep 2 pi wherever you want. Instead of x cubed dx, I'm going to write dx by 36. So dx by 36. And instead of square root of this, I'm going to write u square root of u. So then this becomes, take 2, so pi by 18 out. Integral of u is u to the power 3 by 2 multiplied by 2 by 3, 0 to 2. Then when you put 1 2, we change the limits of integration, right? So it should be 1 to 145. Should be 1 to 145. And then when you put the upper limit minus the lower limit, you see that this is going to be, so let's multiply it out. So we have, this will cancel. So we have pi by 27, 145 to the power 3 by 2 minus 1 to the power 3 by 2. So this is the answer. Now for the third one, let's just first at least write down the integral. So for the third one, let's see. So we have y equals to x squared. So we can write this in both ways. So we can write either, you can write down s to be, again, if you want to write it in terms of x, we can write it as 0 to square root of 2 pi, instead of y, it's x, because you're rotating around x-axis, 1 plus dy by dx, the whole square dx, which is going to be 0 to 2 square root of 2 pi x, 1 plus, what is dy given by, y is given by x squared, so this is going to be 2x squared, and then we have dx. Now, however, I can write the same thing in terms of the other function as well, in terms of y completely, because this will give me what? This gives me x equals to square root of y. So when x is 0, y is 0. So I have y changes from 0 to square root of y. So what is square root of y? It's 2 to the power 1 by 4. So in that case, I can also write this as 2, 0, 2 to the power 1 by 4, 2 pi y. Now I'm going to write, so 2 pi, so now the length is what? Length is x, yeah, when you're rotating around x-axis. So now what is x in terms of y? It's going to be square root of y, square root of, so this is going to be x, but written in terms of y, so square root of y, 1 plus dx by dy. So my x is square root of y, so dx by dy is 1 by 2 root y, so 1 by 2 root y, the whole square dy. So it can also be written in the following format. Okay. All right, now let's look at this problem. So find the area of the torus, surface area of this torus. So this is a torus, like a donut, and we want to find out what is the surface area of this donut. So how do we go about it? So let's look at the cross section like that. So if we look at the cross section, we will have, so this total distance is r, and this part is r, and you're rotating this semicircle. You're actually rotating the whole circle, but what we'll do is we'll rotate the semicircle and multiply it by 2. Okay, and then we have this distance is r, and this distance is small r. So what is this point going to be? So this point is going to be r minus small r. This is going to be r plus r, because we need to find out limits of integration. And now, what is the equation of this semicircle? The equation of this semicircle is the radius is r, the center is r comma 0. So equation of semicircle is x minus r the whole square plus y square equals to r square, right? Small r square, not big R square. So x minus capital R square, because that's what the center is. This point is r comma 0 equals to small r square. So therefore we get equation is what? Y equals to square root of r square minus x minus r the whole square. So this is our y. So what is my formula? So first of all, I need, so f prime x, right? So f prime x, which is y, is going to be 1 by 2 r square minus x minus r the whole square multiplied by derivative of inside, which is going to be minus 2 times x minus r. These signs will cancel, so we'll have minus x minus r times r square minus x minus r the whole square. So this is your y prime. So then what is your s? Your s is, what is your x changing from? X is changing from r minus r to r plus r. 2 pi x 1 plus f prime x the whole square dx. And now since we are only looking at the upper part, right, and we still have to consider the lower part as well, we'll basically multiply that by 2. So this is going to be 2 r minus r, r plus r in bracket 1 plus this square. So x minus r square times r square minus x minus r square square root dx. Now if we simplify this out, this is going to be 2 r minus r to r plus r. Inside we'll have r square minus x minus r square plus x minus r square square root divided by r square minus x minus r square dx. So these guys will cancel off. So we are left with 2, and we have 2 pi x, which we shouldn't forget. So we have 2 pi x. So 2, so that will become 4 pi outside, 4 pi x here. So there's an x here. Let's not forget that. So we have 2. If we simplify, the numerator will become simply r. So 2r, r minus r to r plus r. So 2 came out. So we have 4 pi, and then we have, so 4 pi. So 4 pi. So we have 4 pi r upon square root of times x. So r came out. So x upon r square times x minus r the whole square square root. Now let's do some transformation. So notice that what kind of function is, so we can take x minus r to be u. So let x minus r be u. So then what do we get? We get, this becomes 4 pi r. So now this will imply what will happen when x is r plus 1. So this implies when x is r plus 1, x equals to r plus r would give me u equals to r. And when x is r minus r, then u becomes minus r. So the integral limit will also change from minus r to r. X will transform into u plus r. Denominator will change into r square minus u square du. Why? Because du equals to, because if we take here, we get du equals to dx. So now let's break this. So this is going to be 4 pi r minus r to r u upon square root of r square minus u square du plus minus r to r upon square root of r square minus u square du. The reason for separating this was this is an odd function, right? So this becomes, and it's integrated from minus r to r. So that will become 0. So we have 4 pi r. Now this is an even function, so it will become 2 times that thing, and r you can take out, integral 0 to r 1 by square root of r square minus u square du. Now, what is the integration of this guy? Integration of this guy is sine inverse of u. So pi 2 r, so 2r, so 2r, sine inverse of u by r from 0 to r. When it is r, you get pi by 2. When you put 0, you get 0. So you can cancel this, you get 4 pi. So this integral is going to be 4 pi times pi square. This 2 and this 2 will cancel, r. So this is a formula for the surface of this area of this torus.